Right, so you should be able to access this in your class notebook. If you can't access in your class notebook, you should do it on a piece of paper, and then you'll be able to upload it. So first things first, get your date in. The title today is practical skills, keywords, then variables, hypothesis, analysis, and mean. And then there are some do now activities. What I'd like you to do then is pause the video and have a go at the do now activities. So the answers for the do now activities: what is the chemical formula of water? H2O. Name 3 subatomic particles in an atom. You've got your proton, which is positive, your neutron, which is neutral, and then your electron, which is negative. Which gas do we breathe in? We breathe in oxygen, which is O2. Which gas do we breathe out? That's CO2. Name the 8 planets. So my very easy method just sped up naming, and then you could put planets for Pluto. Okay, so you've got Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Which are the rocky ones? The first 4 are rocky, and then the other ones are gaseous. Okay, so we're going to be looking at practical skills today, thinking about using key practical skills, so different practical skills for data collection and analysis. So we're going to have a go at identifying our variables, looking at controls, looking at hypotheses and accuracies and precision. So there's loads of different things we're going to look at today. Keywords, they should be put in either your class notebook or on the paper, depending on how you're doing it. So the first thing we're going to look at is our variables. There's 3 different variables, okay? You have to be able to identify them, you have to be able to comment on them. So the independent variable, the variable that is altered during the scientific experiment. Sometimes we say changed. So the variable that is changed during the scientific experiment. Okay, the dependent variable then, the variable that is tested or measured during the scientific experiment, and the control variable is the one that is kept the same. Okay, any change to a control variable would result in invalidated results. There's only one thing we change. There's always only one independent variable. You can have numerous control variables though. Okay, so in your there is an opportunity to write down your variables. So if you want to note down your variables, and then there's an opportunity looking at what you've noted down in terms of your variables. Make sure you pause on the screen so you can copy it down properly. Look at now, and then we're going to have a go at a little review. So just a quick true or false. So you just need to write down the numbers and then T for true or F for false. Pause the video, have a go at them, and then I'll put the answers up. So the independent variable is the variable being measured. That's false. It's the variable that we change. The dependent variable needs to be controlled. That again is false. The dependent variable is the one that we measure. There can be more than one control variable. That's true. If there are no control variables, the investigation would lead inaccurate results. Again, that is true. Okay, so give yourself a mark out of 4. And then we'll go on to the next. So, there's the answers there. So, I'm going to have a go at this one. You're just going to listen, have a think about it. First thing you need to do is always write down the side IV, DV, CV, and then think to yourself, what does the IV do? The IV is the thing that we're changing. What's the DV? The thing that we're measuring. What's the control variable? The thing that we keep the same. Okay, and then for every question, you need to think about what are we changing, what are we measuring, what are we keeping the same. So a study was done to find if different tyre threads affect the braking distance of a car. Okay, so what are we changing? The tyre threads. What are we measuring? The braking distance. And then what kind of things do we need to keep the same? What kind of things do we need to keep the same? The weight of the car, type of car, the surface that the car's on, weather conditions. Okay, they're just a couple. Okay, so with the control variable, we need to think about everything else that could change to affect the results. And there we go. There's just the answer plotted in there. So another one then, what I kind of like you to do is pause the screen and have a go at it. Okay, if not, don't worry, I will go through this one again. You can note it down. Up to you. So, independent variable. What's the independent variable? The one that we change. What's the dependent variable? The one that we measure. What's the control variable? The one we keep the same. So always do that. A study was done to find if a material of a golf ball affects how far it travels. So what are we changing? The material of the golf ball. What are we measuring? How far it travels. What are we going to keep the same? So what kind of things do we need to keep the same? The size of the golf ball. Mass of golf ball. And there's most probably loads of other ones, but that'll help you. Oh, so mass of the force it's hit with. Again, weather conditions, how far it has to travel. So another review now. There are 1, 2, 3, 4 to have a go at. Exactly the same thing. So in your notes, put it down as how I've been doing it. So write number 1 and then go IV, DV, CV. So that's how I'm expecting it to be laid out. So you can tell me exactly what there is. And especially if you still need to do that, change, measure, same. Okay, and then you write out what you're changing, what you're measuring, and what you're keeping the same. Okay, pause the screen and then the answers will pop up in a minute. So for the first one, for number 1, what were we changing? We were changing the speed. What were we measuring? We were measuring the time. And what were we keeping the same? The distance, okay? Obviously with control variable, you might have come up with loads of different ones, but I've just picked the most obvious ones. For number 2 then, what were we changing? We were changing the amount of water. What were we measuring? The height. And what were we keeping the same? Light, CO2 levels, soil, so what was in the soil and the amount of light. 3 then, what were we changing? The air temperature. What were we measuring? The speed of the time to bake the cake. What were we keeping the same? Ingredients, heat source, so was the oven the same? What kind of bowl we put it in. And then number 4, what were we changing? The volume of water. What were we measuring? The number of lemons. And then what were we keeping the same? The light, CO2 levels, and again, the soil. So anything to do with plants, think about photosynthesis and what you need to keep the same. Moving on then to the next little bit in terms of measuring skills. Hypothesis in practical work is a prediction that is supported with an example. The explanation might use previous knowledge or scientific evidence. A hypothesis is not a question or a prediction. It is a statement that can either be proven correct or incorrect by controlled, repeatable testing. So a hypothesis is pretty much the statement that you make at the beginning of an experiment as to what you think is going to happen, and then you then do the experiment to prove whether it's correct or incorrect. So the purpose of a hypothesis is to think about a particular scenario, okay? So when we're writing our hypothesis, we need to think of 2 things: the experimental variables, so the dependent and the independent variables, and whether it will be measurable and testable, okay? So in your books, you might want to write a little definition of a hypothesis, and then we're going to move on to writing our own hypotheses. Okay, so this is the success criteria for writing a hypothesis. So we'll be thinking about this. I'll do a couple with you and then you can have a go at doing. Read the question. Think about the scenario. What is it asking you? This is just an example. Are tall people faster than short people? That's the question that you're thinking about. Then identify the variables. What are we changing? Well, tall people, short people, so we're changing the height. What are we measuring? How fast they are. And then what kind of things we have to keep the same. Distance, conditions, clothing. Make a prediction based on your scientific knowledge. I think that tall people are faster than short people because, okay? And then all you have to do is delete the I think bit, and that becomes your hypothesis, okay? It's no longer an I think, it's a statement that you are making, and then you will test during your experiment. So, this is the first one. Is there a relationship between the stretch on a spring and the amount of mass you can add on the spring? So first thing I did was work out the variables. So I worked out my independent variable, which was the mass added, worked out my dependent variable, which was the distance of the stretch, and then I looked at my control variables, same spring, same person measuring, okay? So write your prediction. I think that the larger the mass, the bigger the stretch on a spring. Okay, you can then go on to write a because, but I'm going to leave that little bit for you. Okay, so think about it as an I think that, and then all you do is just delete the I think that. Okay, so the hypothesis then is the larger the mass, the bigger the stretch on the spring. Okay, and then you can write your own because. So there's an example to have a go at together now, thinking about the success criteria. So what's the question asking me? Read the question. Does the amount of sunlight affect how fast a plant grows? So then we're going to do our IV, DV, CV. So you can see how it links to the first activity you had to do. Does the amount of sunlight affect how fast a plant grows? So IV, what we're changing, amount of sunlight. DV then, how fast the plant grows. And then thinking about it, soil would be a control variable, water access, CO2 levels, because it's a plant, we're thinking about photosynthesis. Okay, so writing my hypothesis now. I think that, and remember we're going to delete it in a minute because that's the third part of our success criteria. I think that the more sunlight there is, the quicker a plant will grow. Okay, and then you could write something here about photosynthesis and making glucose and how that can then be used to make energy to help the plant grow. Okay, but just because we're trying to do a lot here, I'm just going to leave it at the I think that bit. And then the last little bit you need to do then is remove the I think that. So then the more sunlight there is, the quicker a plant will grow, and then you can fill in the because bit. So what I want you to do now, this is one from a proper past paper, but anyone can have a go at it. It's an awful lot going on. Read through it, pause it, think about your IV, DV, CV, fill that in, and then see if you can write a hypothesis. Remembering, think about writing a prediction and then delete the I think that. The most important thing to do though is to read the question. Read the question, start filling in your IV, DV, and your CV. So everyone should have had a go at this question now. So the IV was the concentration of the substrate. Don't worry what the substrate is, but the IV was the concentration. The DV was the rate at which the enzyme controlled reaction took place. And then things you had to keep the same: volume, temperature, type of enzyme. Okay, so I think the higher the concentration of substrate will increase the rate of enzyme controlled reaction, and then you just delete that. So it becomes the higher the concentration of substrate, the quicker the rate of reaction. And then another one then, exactly the same thing. Pause the video, have a go, read through the question, do your IV, DV, CV, and then think about writing your prediction, and then cross out the I think that, so it becomes a statement for your hypothesis. Pause the screen and have a go. Okay, so again, what are we looking at? Your task is to investigate how the resistance of a thermistor changes with temperature. So what are we changing? The temperature. What are we measuring? How much resistance there is. Okay, it says you'll start with 65 and then allow it to cool. But you would be thinking about components in the circuit. So what's in the circuit? Length of wire, same devices. It's a bit of a hard one if you haven't done a lot with circuits, okay? And then delete the I think that the resistance will increase as the temperature increases. But you could have written the resistance will decrease as the temperature increases or decreases, okay? Remember, it doesn't have to be true. It just has to be written as a statement. So even if you got it wrong, as long as you had to go writing it as a statement. So we're going to move on now to accuracy and precision, okay? Accuracy is how close a measured value is to the actual true value. So say something had to be 10, you would have really accurate results if you got 10 or 10.1, okay, or 9.9, values that are really close to the true value, okay? Precision then is how close your measured values are to each other. So you might not get them close to the true value, but if all your answers are really close together, then that's a precise value, okay? So you want to note down these definitions and think about them, okay? So often we use a dartboard. So the true value would be the middle, the bullseye. So that would be the true value. So if your results were really close to the true value, then they'd all be on the bullseye, and then you'd say that you were really accurate. Okay, so this here we say is high accuracy because they're all quite close to the bullseye, low precision because none of your values are close together. Okay, this one then we say it's got high precision because they're all really close together. However, the true value is the bullseye and they're not close to it. Okay, and then finally this one then we would say they've got high accuracy and high precision because they got it on the true value, which just means that you're very accurate, but they're also really precise because they're close together. Okay, so make sure you note down your definitions of accuracy and precision. Okay, if you are playing football, you always hit the right goal post instead of scoring, then you are not accurate, but you are precise. Okay, so another way to remember it is accurate has got a C in it, so accurate is correct, and then precise has got an R in it. R is repeating, so hitting the same spot over and over again. May not be the correct spot, but you're hitting the same spot over and over again. So there's just another way that might help people remember it. So, little review, you've got all different dartboards now. You need to comment on whether they are accurate or precise. So press pause and then in a minute the answers will appear. Okay, so this one then, remember we're aiming because our true value would be the bullseye. So this one is definitely accurate and they're all really close together. So I would say it's precise. Okay, this one then, remember the true value is the bullseye, so it's not accurate and they're not precise because they're not close together either. This one then, they're all quite close to the bullseye, so I'd say it was accurate, but they're not really grouped close together, so it wouldn't be precise. Okay, so another thing that you need to think about during a experiment is the resolution. So the smallest measurement that can be made using a piece of equipment. So if something has really high resolution, you can use quite a lot of figures, you can count quite a lot of decimal places. Low resolution then is maybe when you get one decimal place or not any decimal places. So if something's got high resolution, you can count loads of decimal places and it will help you. So what is the resolution? So Jamie is measuring the temperature of his tea. His measurements include 2.4 degrees Celsius, 2.6 degrees Celsius and 2.5 degrees Celsius. What is the resolution of the thermometer? So you'll get asked this question quite a lot. We've measured it to one decimal place, so it would be 0.1. So that was what the resolution of the thermometer would be. Okay? So what I want you to do is pause the screen, think about the example I've given you, and then have a go at answering these ones, thinking about what the resolution would be, and then I'll pop back up with the answers in a minute. Okay, so the answer to number 1, they've measured it essentially to 2 decimal places, so the resolution would be 0.1. Okay, the next one then, they have measured it 2, 3. Doesn't matter about the numbers in front. So always thinking about the largest, the decimal place. Next one, 0.1. Next one then was loads of numbers. Okay, so make sure you counted them properly. And then finally, the bottom one. Okay, so you always use the number 1, and we are looking for which ones have got the best resolution. So if we were to use a piece of equipment, we would say that this is a high resolution, that's a high resolution, whereas that's a really low resolution, and these are quite low. So the higher the resolution, the more accurate your results will be. You know how close you are to the true value. Then finally, we are going to do a little bit of analysis of data. So this is quite a mathsy bit, but it's really important that we get practicing already how we analyse data, okay? So before we get started, or before I start giving out the answers, have a think. Which ones of these have you heard about in maths before? Which ones can you use? And which ones are you a little bit confused about? Note down the ones that you know you can already use. Pause the video, have a go. Okay, so mean is sometimes called the average. And to work out the mean, you add up all your values. And then divide by the number of values. Okay, the median is the middle value, and we'll go through how to work these all out now. Mode is the most common. Range is the largest value. Take away the smallest. And then anomaly is a value which doesn't fit. So what we're going to do now is look at some sets of data, and we're going to try and work out all these different analysis of data because we don't know which one you could be asked, and it's very important that we practice these. You can use a calculator, but I'll go through a couple of things when we are using calculators that could go wrong. Okay, so I do then. Thinking about a couple of ones that we'll need to do. So we're going to have a go at doing nearly all of them. Mean, mode, median, and the range. Okay, so these are the kind of things that they might ask you to work out. First things first, they might ask you to look for an anomaly. With these, all the values are quite close together, so I wouldn't say there was an anomaly, so we don't really need to worry about anomalies. You'll know when there's an anomaly because it'll be a number that really stands out. Okay, so range then we said was the largest, take away the smallest. That's most really the easiest one to start with. So your largest number is 225.0 and your smallest number is 23.0. In some exam situations, they will accept that. I would prefer for you to write it as though it was 2. Okay, your range is 2. Okay, median, to work out the median, you need to put them in the correct order. Okay, so you need to start from your smallest, which is 23.0, 23.5, 24, 24.5, and 25.0. Okay, so the middle value would be 24 because it's the one in the middle. There is no mode because there's no most common. Each number appears only once. Then to work out the mean, you need to add up all them numbers. So you can either do it in your head or you can do it on a calculator. It is entirely up to you. But the first thing you're going to do is add them all up. So make sure you add them all up first. So when you're on calculator, just add up all the numbers you've got, and then you need to divide by how many numbers you've got. So you've got 1, 2, 3, 4, 5. So you do 120 divided by 5, and that will give you 24. Okay, so the mean is 24. Okay, be really careful that you add them all up first. Press equals before you do the dividing. So I've done one. This is another one now to have a go at and practice, okay? So we've got mean, mode, median, and the range, okay? So the range then is the smallest number. So the largest number, take away the smallest number. So the largest number is 0.8. 0.6 and the smallest number is 0.59. Again, some people accept it like that. I would like you to get practicing taking them away from each other. So the range between your numbers is 0.27, okay? Mode then, most common number. If you notice, you've got 2 of that, so the most common number is 0.82. Remember to work out the median then. You need to put them in an order. So start with the smallest. Okay, so the median is the middle value, so it's going to be a value between these two because you've got a number either side. So your median is actually going to be 0.83. Okay, with the mean, you might want to think about an anomaly. So an anomaly would be a number that doesn't fit. So I would take that out when calculating your mean. So calculating the mean, then we want to add up these 5 numbers by here. Okay, so add them all up, press equals, and then count how many numbers. Because we've removed this number as an anomaly, we've removed this one as an anomaly, we're now only using 5 numbers. So we will divide it by 5. And then that gives you the answer of 0.838, or you could round it because that number is bigger than 5 to 0.84. Okay, so if you go over, there are 1, 2, 3 for you to have a go at, and it says mean, median, mode and range for these 3 sets of results. Pause the video and have a go. Right, the answers are up on here. Be careful when calculating the median that you put them all in order and you still include the larger value of the anomaly. The anomaly only comes out when you're calculating the mean, okay? And a couple of them don't have modes because they don't have most common values. Okay, so pause the screen, write your answers in. There is a challenge exercise on your class notebook, and then make sure you submit your work. And if you've got any problems, please email your subject teacher. Thank you.